Hello, today I wanna do a simulation, applied force simulation. Okay, first of all, you need to click this on and you need to set the friction halfway. Then put the 50 kilogram box on the track on the plane. Next, we need to increase the Newton, increase the applied force. As you know, the formula of this force, applied force equal to friction force. So if you want to move this box, you need to increase the applied force. As you see here, the box start to move as the applied force increases. The applied force at 150 Newton to the right. The friction force is 97 Newton to the left. So sum of force is 53 Newton. Then okay, that's all from me.
Part B, which is coefficient or static friction. First of all, open the link that is given in lab sheet 3. Then, select forces followed by inclined plane with friction, two masses and pulling. So here you can do your simulation. So according to the procedure, first you set your degree at 0. Set your angle at 0 degree, mass of M2 as 10 kg and coefficient of friction between M2 and surface as 0.25. Okay, then you can select show numerical values so that you can observe the force of kinetic friction, acceleration, tension in string, time taken and also the velocity. So now we can start run the simulation. So when the mass of M1 is 7.5, the simulation is run. So now the next procedure is slowly reduce the mass of M1 until the M2 is barely moving towards M1. So when I try to doing this, when the mass of M1 is in 2.6, the simulation is still run. You can see here. Whereas when the mass of M1 is 2.5, M1 is not moving. So once you observe the data, you can write it back in table 1. So now the next procedure is reduce the mass of M2 according to table B1, which is 8, 6, 4 and 2. Once you change the mass of M2 over here to 8, you can record the data here. So move on to next step, which is change your angle to 30 degree. Mass of M2 as 10 kg and coefficient of friction remain the same 0.25. Run, click run and observe. Then record your observation here. So when the weight of M2 is 10 kg, the load of angle is 7.2 and M1 in Newton it is 70.6. So the same thing you have to do here, which is reduce the mass of M2 according to table B2 and you should reduce the mass of M1 until the M2 is barely moving towards M1. In this case, when the mass of M1 is 7.2, it's still moving, whereas when it is 7.1, it's not moving at all. Okay, moving to next step, where the angle set as 0 degree, mass of M2 as 10 kg, and coefficient of friction between M2 and surface as 1. Right. You can see that it's not moving at all, even though you change the mass of M1. So when I record, you can see here, when the weight of M2 is 10 kg, although you change the mass of M1, it is not moving at all. Whereas when it starts to change the weight of M2 to 8 and more on, it changes. Next step, change the value of angle as 30 degree and mass of M2 remain the same. Coefficient of friction also remain the same. Click run and observe. You can see that it is not moving at all, whereas there is no friction. Same goes to 8 kg. You couldn't see any changes, it just remained the same. But once you change it to 6 kg, when the mass of M2 is in 6 kg and the mass of M1 is 8.2, 8.3, yeah, it's moving. So there is friction. Move on to the weight S4 and 2 and observe what's happening here and record it in your lab sheet.